Let's now look at the graphs of exponentials and logarithms. I've drawn here in pink or in purple, draw a graph of an exponential function, a random one with base a. And here in orange, I've drawn the graph of a logarithm base a, the same base of x. You already can see here a trend, which I'm going to explore later on as I speak. So let's start looking at characteristics of both. The exponential function crosses the y-axis at point 0, 1. When x equals 0, the result is going to be 1. So at 0, 1, you have here a point. On the other hand, the logarithm crosses not the y, but the x-axis at point 1, 0. When you have here x as being 1, logarithm base a, whatever it is, of 1 is going to be 0. You have all real numbers as the domain of the exponential function. X can be anything on the x-axis. On the other hand, it's the y, the values that y can take on the logarithmic function, that can be everything on the real numbers. The range of the exponential function is all positive real numbers. Here, the exponential function can take any positive value of y. It's the range, that is the range of the logarithmic function. It can take any positive value of x. You can write any positive value of x, but not any negative value. The exponential function passes, by definition, through points 1a, 2a squared, 3a cubed. That one I didn't put because of lack of space. On the other hand, the logarithm, you will have points, as you can see here, a1. If you substitute here x by a, you have logarithm base a of a, which is 1. If you substitute x by a squared, you'll have logarithm base a of a squared. Applying that rule that you learned before, the square goes out and multiplies by logarithm base a of a, which is 1. So you'll have just 2. Doing the same thing with a to the power of 3, you'll have, when x equals a to the power of 3, the value 3, etc. As you can see here, you already knew that the exponential function, the gradient increases forever. On the logarithm, it decreases forever. It tends to 0. Here it tends to infinite. As you go that way, it tends to 0. As you go this way, closer and closer to 0, it tends to infinite as well. For any positive value of x, the exponential function is going to be contained between 0 and 1. Any negative value of x, the exponential is contained between 0 and 1. For any value of x between 0 and 1, the logarithmic function is going to be negative, tending to infinite as x tends to 0. You will never have logarithm of 0. That's an impossible value to get because it tends to infinite. So you already guessed it. That's why I have here the line y equals x. 1 is going to be the inverse of the other, represented here on the line y equals x. This is just a sketch, but this line over here is supposed to be the reflection of this line over here on the line y equals x. Let's see some exercises and equations that you can have with logarithms. So you already know that if you have a to the power of x equals b, this is the same thing as writing x equals logarithm base a of b. So let's say that you have this simple equation. 2 to the power of n equals 1000. You want to get the value of n. So n is going to be the logarithm base 2 of 1000. Go to your calculator, put 2 as the base of the logarithm, write 1000 in front of it, and this is what you will get to 2 decimal places, 9.97. Let's say that you have this, a little bit more complicated. 3 to the power of 2x plus 2 times 3 to the power of x equals 15. So you have to look at this and see that this is a quadratic in disguise, or at least you can turn this into a quadratic. If you apply one of the rules and you write this as 3 to the power of x squared, then you'll see that you can use a change of variable in which u is going to be equal to 3x and turn this into this. Then you solve it for u. Here it's easy, you can factorize it into u minus 3, u plus 5. So you have values of u of 3 and 5, and then you undo what you did a little while ago. So you actually have 3 to the power of x equals 3, or 3 to the power of x equals minus 5. So x equals logarithm base 3 of 3, or x equals logarithm base 3 of minus 5. As you can see here, the domain of the logarithm are positive, so you don't have logarithm of negative numbers. So this is going to be impossible. So the only possible answer is this one, logarithm base 3 of 3, which you already know is 1.